Hello everyone, it's a pleasure to introduce our research entitled on the analysis of polytetrafluoroethylene modified with nano zinc oxide and silicon dioxide, authorized by Professor Maruf Hijazi, Professor Rasha Ghunem, presented by Dr. Hend Ezzat. We will start with our overview consisted of introduction, computational details, building model molecule, interaction of polytetrafluoroethylene with different metal oxides, quantitative structure activity relationship calculations, then our conclusion. Firstly, we will introduce our work. Various synthetic polymers known to have impressive corrosion resistant and electrical characteristics, low coefficient of friction, high temperature resistant, and cost-effective materials, among other characteristics. Polytetrafluoroethylene considered as polymer matrix with chemical and thermal stability with a small surface energy. To increase the surface energy and stability of polytetrafluoroethylene, we suppose to introduce nanometal oxides to polytetrafluoroethylene matrix. According to the physical properties determined by molecular simulation, molecular modeling are assumed to be powerful signs to electronic properties and moreover for the reactivity of such investigated interaction. Our computational details, we used Gaussian ZnO program to calculate the interaction between polytetrafluoroethylene with metal oxides such as zinc oxide and silicon dioxide. All model structure computed using DFT theory at the B3 level using the LAN L2DZ basis set. Homolomo band gap energy, total dipole moment, and molecular electrostatic potential as contour, all computed using the same level of theory. Also, quantitative structure activity relationship calculated using semi-empirical BM6 level. First, we building our model as 4 units of polytetrafluoroethylene interacted with 4 zinc oxide particles and 4 silicon dioxide particles and a combination of the two metal oxides through the oxygen atom of metal oxide. For this study, we calculate for all structures homolomo band gap energy and molecular electrostatic potential. From result, homolomo orbital distribution were localized around the metal oxides and the total dipole moment of polytetrafluoroethylene increased with decreasing band gap, and the most enhanced structure was polytetrafluoroethylene with 4 zinc oxide silicon dioxide layer by layer, with band gap energy equal 0.6 electron volt. Then we suggested to raise the number of interacted nanoparticles to 8 atoms to study the effect of rising on electronic properties. For this study, we calculate all structure homolomo band gap energy and molecular electrostatic potential. According to homolomo calculation result, the orbital distribution were changed with rising the nanoparticle numbers. That the total dipole moment of polytetrafluoroethylene increased with decreasing band gap energy, and the most enhanced structure was polytetrafluoroethylene with 8 zinc oxide silicon dioxide particles layer by layer with band gap equal 0.27 electron volt. Also, the molecular electrostatic potential mapping reflects that nanometal oxide increased the reactivity of polymer matrix, and with rising number of nanoparticles, the reactivity and electronic properties increased also. Also, quantitative structure activity relationship calculation, which study the reactivity and stability of chemical structure by calculating some descriptors such as total energy, heat of formation, ionization potential, log B, polarizability, molar refractive, and molecular weight, From all data, the most reactive and stable structure was polytetrafluoroethylene with 8 atom zinc oxide silicon dioxide layer by layer. So we can conclude our work that polytetrafluoroethylene interacted with nanoparticles such as zinc oxide, silicon dioxide, and a combination of the two metal oxides were computed using TFT calculations. Polytetrafluoroethylene interactions with metal oxide significantly improved in electronic properties, especially polytetrafluoroethylene interacted with zinc oxide, then silicon dioxide. With rising nanoparticles to 8 atoms, the electrical activity of polytetrafluoroethylene was highly increased. Also, quantitative structure activity relationship indicated that the structure polytetrafluoroethylene with 8 atoms of zinc oxide and 8 atoms of silicon dioxide is the most enhanced structure with high thermal stability. Accordingly, polytetrafluoroethylene might serve as anti-corrosion layer throughout space mission. Finally, I would like to thank you all for attention, and I am waiting for any questions. Thank you.